Hi everyone, this is Mr. Cole, and today we'll be learning about Chapter 6 Algebraic Fraction, more specifically, the simplification of the algebraic fraction. So in this video, we'll simplify common factors between the numerator and denominator, as well as to factorize numerator and denominator before we simplify. So let's recap to a simple problem as you have seen in primary school. How do we simplify the fraction 24 over 42? So some of you may have known what we can do is we divide by the same number in the numerator and denominator. Let's say we divide by 6 in the numerator and denominator, we will get 4 over 7. Correct? And then this is what we call our simplest form because we cannot divide the numerator and denominator any further. However, what you're actually doing is forming common factors. Alright, so 24 can be split up into 4 multiplied by 6 and 7 multiplied by 6. So what we have is the common factor 6 in both the numerator and denominator, and after we cancel out them, simplify them, we get 4 over 7. That is the key gist of simplification of fraction. Now let's apply them to algebra. Let's look at this question. We have 3x power 4 over 9x cubed. So for the same thing, right, we are just trying to identify common factors. So 3 and 9. The number 3 and 9, we have a common factor of 3. So what we do is just divide the top by 3, left with 1, right? And then divide the 9 by 3, we left with 3. Next, let's look at x. So in this case, what we have is x power 4. Correct? But we know that x power 4 can be written as x multiplied by x multiplied by x multiplied by x. And the denominator x cubed can be written as x multiplied by x multiplied by x. So what we are doing when we are simplifying algebraic terms is we are just dividing the top numerator and bottom denominator by the same term. So we divide x at the top and bottom, basically we are sort of cancelling each of them out. Alright, and we do it for the second one, and we do it for the third one. Now, we only stop cancelling when there are no other common factors left. So what do you notice? The top is left with x to the power 1, but the bottom is just 1. Alright, there's no more x already. So essentially what we did is we cancel out the entire of the bottom term to form the number 1, and then we cancel the top one to form x power 1. So lastly, we are left with the term x over 3. Is that okay, everyone? Okay, so how do you get x over 3? Because in the top part, we are only left with x power 1 multiplied by 1, which just gives you x. In the denominator, we get 3 multiplied by 1, because we have cancelled out all of the x terms already. So we are left with x over 3. Now let's do the same for the second question. We have y x plus y cubed and y cubed x plus y squared. Okay, let me show you the long method first. Alright, so first thing what we're going to do is we're going to expand out everything. Alright, what we're going to have is y x plus y x plus y x plus y. Total we have 3 times. Alright, over y times y times y, and then we have x plus y x plus y. Okay, now we'll simplify by cancelling out common factors. So y and y we can simplify. X plus y simplify. X plus y simplify. So now what we are left with is just x plus y over y squared. Okay, now what is the first method? The first method is just simply by comparing the powers. Okay, so let's look at the common factors y first. In this numerator, it's actually y to the power 1. Now 1 and 3. Who is higher? Of course, 3 is higher, right? So what we do is just subtract the higher power from the lower power. So first thing, we eradicate our y power 1. And then the top part, we just take 3 minus 1, which gives us 2. Alright, that's how we can simplify it. Now, let's look at x plus y term. We have x plus y cubed at the top and x plus y squared at the bottom. So same thing, we take the bigger one and we minus away the smaller one. So 3 minus 2 gives you 1. And then for the bottom one, we just cancel totally. Okay, and that will just give us x plus y to the power 1 over y squared. Is that okay, everyone? Good. Now let's look at another fraction over here. 26x cubed x plus y squared over 63x. So instead of writing everything out, let's simplify just by the power. So let's write it first. 26x cubed x plus y squared over 63x x plus y power 4. Now 26 and 63. What are the common factors between them? Oh, sorry. Okay, so there are no common factors, so this one we leave it as untouched. Okay, let's look at x cubed. Can we simplify x cubed and x? Yes, right, so this one is simplified totally into 1. But x cubed, because 3 minus 1 give you 2, so then we can simplify to x squared. Okay, for next one, we can simplify x plus y squared whole thing. And then for the bottom, alright, denominator, this just becomes 2. As we take 4 minus 2 to give you the remainder 2. And our final answer is just 26x squared over 63x plus y squared. Is that okay? Right. Now, let's look at question 4. Question 4 is then when we incorporate factorization. Okay, so for such question, if we can factorize first before we simplify. Okay, so I repeat again, factorize first before we simplify common terms. So let's look at this question. Can we factorize the numerator? Because there are 2 terms and there are common factors. So indeed, we can factorize the numerator. So what we get is we factorize out a. Oh, let me use it in black. Okay, get factorize out a squared divided by a gives you a, and 4a divided by a gives you 4 over 3a. Only after you factorize out the common terms, then we are able to simplify the common terms between the numerator and denominator. In this case, it's quite obvious. A is the one being common. Alright, so what we do is we are going to simplify them. Right, and what we are left with is just a plus 4 over 3. Okay, hope everyone's clear with that. Now let's look at another question. So same thing. Alright, the numerator we need left with 1 term, cannot factorize it any further, so let's factorize the denominator. So what we get is 3t in the numerator equals t bracket t minus 2. Now we have our common term t. Let's simplify them, and we are left with 3 over t minus 2. Same thing, factorize first, then simplify the common terms. Now, question 6. Question 6, just a little level higher. We factorize both the numerator and the denominator. Okay? So in the numerator, we can factorize out x to get x minus 3. In the denominator, we get 3x minus 9. There is no common terms in terms of the algebraic term x. However, there's a common term when we compare the numbers. Alright, the coefficient and the constant, 3 and 9. So we can factorize out 3, and what we are left with is x minus 3. For this question, you'll notice that we are actually not dividing or simplifying the term that we factorize out, but rather the term that is in the brackets. So now we have a common term of x minus 3 and x minus 3 in the top and bottom. We can actually simplify that. Alright, which gives us a simplified fraction of x over 3. Okay, so just for you to note, we don't always have to simplify the term on the outside of the bracket, but sometimes if you have common terms within the brackets, we can also simplify them. Alright, now when we have a complicated 3-term quadratic expression over here, we have an x squared term, we have an x term, and a constant term. What do we do in this case? Then the hint is to use box method for factorization of quadratic term. So if you still remember, we first draw our box, okay? And then we draw our x squared term in the top left. We draw our constant term in the bottom right. Alright, and let's try to solve it. So we want x at the top, x over here, alright, to give us our x squared. But then what two combinations should we use to give you a combined factor to multiply together to get minus a negative 4, right? So let's try negative 4 and 1, right? Let's see if it's work. So 1 times x give you x, negative 4 times x give you negative 4x, right? So if you still forget how to do the box method, what we are doing is we are just multiplying the rows and columns to get our common, to get the missing terms, right? So x multiplied by 1 will give you x. Now what we do is we add the diagonal terms, and this will give us negative 3x, which is what is given in the question, right? So that's how we know that our factorization is correct. So what are we left with is form our equation. Sorry, form our fraction. So we get x minus 4, x plus 1. Okay? Over 3x squared minus 12x. We take out the common term, which is 3 and x. After take out a common term, 3x squared divided by 3x, we just left with x. Negative 12x divided by 3x, we're just left with negative 4. Are there any common terms to simplify? Yes. X minus 4 and x minus 4. What we are left now with is just x plus 1 over 3x. Okay, so same thing, simplify, factorize out all terms as much as you can, and then simplify the common terms. We left with a very nice fraction. Okay, let's try one more. Alright, let me demonstrate the box method one more time. So in the top part, same thing, we use our box method. Okay, first draw our box. We put our p squared term in the top left and our constant term in the bottom right. Right? So we get p and p. Now, look at the middle term here, negative 7p. However, our last term, 12, is a positive term. So how can we have two numbers multiplying to get a negative number? Correct? So then that's a hint that your second number must be a negative number. So then over here, we'll try negative 4 and negative 3. So now, what is negative 4 multiplied by p? Then we get negative 4p. What about p and negative 3? What do we get? You'll just get negative 3p. And then when we add the diagonal terms, this will give us negative 7p, which is exactly what we wanted. So then let's factorize this. We'll get p minus 4 and p minus 3. In the denominator, same thing, we factorize out the common term, which is 5p. And what we're left with is p minus 4. Now we can see the common term now. P minus 4 and p minus 4. Simplify them. And what we're left with is p minus 3 over 5. Alright. Now, for the last question, we will be using special identity. Okay, in the top numerator, we can simplify by taking out 2 and m. So we get m minus 2. Okay, however, in the denominator, can we factorize this out any further? There are no common terms, n or number, right? The coefficient is 1, so there's no common factor. What can we do? Remember, 4 is actually a perfect square of 2 square. So m squared minus 4 is actually m squared minus 2 squared. If you recall our special identity, a minus b squared actually gives us a plus b, a minus b. Alright, so by comparing the similar pattern a squared minus b squared to m squared minus 2 squared, what we can factorize this out to be is m minus 2, m plus 2. Okay? So our next step would then be to factorize it out further. M minus 2. And denominator we have m minus 2, m plus 2. Okay. Now we can see our common factor, m minus 2 form it. So we can simplify it. And this will give us a final answer of 2m over m plus 2. Is that okay, everyone? So we have come to the end of the video, and I hope you can stick on to see the next video on 6.2 where we learn about multiplication and division. See you in the next video.